Phantom circle. Consider the hyperbola y squared equals x squared plus 25. Now, if x equals 0, y squared is 25, so y is 5 or negative 5, that's here and here. If x is plus or minus 3, then y squared is 25 plus 9, which is 34. So y equals approximately 5.8 or negative 5.8. So putting these points on, we have this one here, this one here, this one here, and this one here. Now the question is, what x values will produce y values between 5 and negative 5 in this space? So here is the equation. I'm going to change it so the subject is x squared. X squared equals y squared minus 25. Then, if y equals plus or minus 4, then x squared is 16 minus 25. So x squared is negative 9, so x is plus or minus 3i, where I is the square root of negative 1. Similarly, if y equals plus or minus 3, then x squared equals 9 minus 25. So x squared equals negative 16. So x equals plus or minus 4i. If y equals 0, then x squared equals negative 25. So x equals plus or minus 5i. Now here's the graph again. And the problem is, where do we put these new points which have imaginary x values but real y values? We need an extra x-axis for these imaginary parts. So we have an imaginary x-axis sticking out here, like this. Now just turn that sideways a bit, and I'm going to put on those points. First of all, 0, 5 is there, and 0, negative 5 is here. Now, the point positive 3i, negative 4 means you go along 3 in the I direction, and then down 4 to this point. And then the other point on this other side is negative 3i, negative 4, so it's along 3 there and then down 4 there. Next one, 4i, negative 3 is along 4, then down 3. Similarly on the other side. And then we have a much more simple one. We have 5i, 0, which is just along the imaginary x-axis, and negative 5i, 0 there. This one is along 4 and up 3, and this is along to negative 4 and up 3, and this point 3i, 4 is along 3i and up 4, and this is along negative 3i and up 4. Now if I join those points, we get an imaginary circle. Now this is the actual graph, and I can move it around like this, as you see. Now an interesting point here is that whenever there is a space or a lack of y values, there is usually a phantom graph that we can fit in the space. Now I'm going to look at a more complicated one just to show you. Now the equation of this curve is y equals x to the power 4 divided by x squared minus 1. So it has two vertical asymptotes, x equals plus 1 and x equals minus 1. And you see there is a space where there are no y values. Well, after a great deal of algebra, I'll show you what phantoms occur in those spaces. And this is the result. These are incredibly unusual, as you can see the blue ones. You'll notice, by the way, that if I draw a horizontal line, there are always 4 x values. Those are 4 real x values. Here are 4 imaginary x values, and down here there would be 2 real x values for the red parts of the curve and 2 imaginary x values for the phantom that goes underneath. So this curve has several phantoms.